in 3, 2. All right, we're live. Lesson 7-1, our first of 3 probably lessons on exponential functions for Algebra 2. Today's date is Monday, January 4th, 2021, the new year. Can't be worse than 2020, right? We'll make it better if we try, right? Objective. Who wants to read that? Wyatt, go for it.
Identify forms of exponential growth and decay and determine how time affects the scale factor.
There it is. That's a mouthful of things. So let's jump right into this. So here's an exponential function. I just randomly chose E because exponential function. I could have chosen any letter, but there it is. Okay, so ignore the function notation. There it is. This is the main guy. You have this capital A, you have this capital B, you have a letter T, and then time down here. Let's analyze all of these 4 pieces. So A is your initial value, which is a fancier way to say it's whatever you start with. I started by sending 10 emails, and as an exponential function, as a chain email, it did blah, 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 whatever. It's your starting amount. And let me color code this too to make it pop out. It'll really make it pop. All right. B is your scale factor. This thing that I talked about right here, scale factor, or Wyatt's talked about in our objective. B is your scale. Cannot spell. Scale factor. i.e., how fast, what am I writing? How fast is this thing growing? It is exponential, so fast, but how fast as an exponential function? Another way of writing this, and I really want this to actually be readable, legible. Another way to write this is your base. What is your base? And I think for basically everything, your scale factor should always be positive. So I'll say it's always greater than 0. What?
Is that really how you spell factor? I thought it was an OR, not an ER.
No, in the top right, you
right.
can see it's an O.
Is that a teacher error?
Yes, sure. This is a teacher error. Factor. Yes, it should be factor. Thank you for correcting that. And notice that the T is just always a Andres, yeah?
Yeah, I just had a question. Do we have to, if we catch a teacher error, can we put it in the extra credit tracker from last semester?
No. I mean, if you want to create a new section to remember, because I haven't given you the paper one yet, that's great. But I will be giving everyone new ones for this next one. Yeah, good question. T is just the variable. There it is. Variable. Let me change the color here. We have to have a variable somewhere, and there it is. Come on, mouse. There you go. It has to be in the exponent. Why? Because it's an exponential function. That's kind of what defines an exponential function. You have a variable in the exponent. So let's just say that's your variable. It's in the numerator of that fraction. And in the denominator of the fraction, you have some units of time. I'm just going to change that color to black. One thing I haven't used yet. And it's just some units of time. So I'll say units of time. And that's kind of important, especially for, is it today's lesson, a future lesson? There's at least one of these 3 lessons where, like, if I give you a time goes right there. It goes in the denominator of the exponential function. Denominator of the exponent of the exponential function. So let's talk about the difference between growth and decay. When things decay, they get smaller and smaller and smaller. If you've talked about radioactive elements or something like that, they have something called a half-life. How many years does it take for you to have half the amount of mass? That means your substance or whatever it is, it's getting smaller and smaller and smaller. Super, super useful for solving crime or doing archaeology. How old is this fossil? Well, using the half-life of carbon-14, or I don't know, whatever you're going to use, you can actually figure out how old things are. So decay is super, super useful to the real world. Exponential growth obviously is really important because you can use it to model, I don't know, things like pandemics. So very, very applicable in either case, growth and decay. So let's first talk about, I don't know, growth. Exponential growth is different than decay. They're opposites of the other. So growth and decay is when a certain part, a certain piece of our general formula is either greater or less than 1. What's the thing that affects the speed? I already talked about it, Charles.
The time. When time would be
No.
greater than 1? Or
So time is the thing that kind of like modulates
oh,
a
the
little
scale
bit. But
factor.
the thing,
Scale factor.
exactly, yeah.
So
The scale
when
factor is
b
the
is
most important.
greater than 1.
Yep,
And
greater
then
than
less
1, and
than.
then that one's gonna be less than 1, exactly. This is kind of the, I don't know, the first really big thing that I'm teaching you right now. Growth is whenever your b is greater than 1. And greater than 1 can mean a bunch of different things. In terms of a decimal, that's like 1.1. 1.1 is greater than 1, therefore it's exponential growth. Or it could be 0.98, which is less than 1. But it could also be a fraction, right? Like something that's greater than 1 could be like 5/4. That fraction is greater than 1. Or if I have the fraction, I don't know, 3/4, that would be a fraction that's less than 1. So it could be fraction form, it could be decimal form. You have to be comfortable with all these things. The main definition is your base bigger or less than 1? If it's equal to 1, congratulations, it's not even really an exponential function, because you have a constant, you have a constant function. And like if I have, I don't know, 2 times 1 to the power of t, it doesn't matter what value of t is, 1 to any power is 1, so your function is literally just 2. So don't make your base 1, because that's too silly. All right, let's talk about how to say the same thing. So I'm just randomly making up numbers. 1, 2, 3 times 1.25 to the power of t. I have an exponential function. Great. So you can say that this grows by a factor of, and then you just say the scale factor. So this thing right here is going to be the scale factor. Why? Because it's using this word factor. Factor means scale factor. And then you say, hey, the scale factor is, well, is it 123 or 1.25? Someone tell me quickly. What is it? What is the scale factor? Is it 123 or is it 1.25? What is the scale factor? Only 2 people know? Oh no, Jose.
Is it 1.25?
Exactly, 1.25. So that's one way of saying it. I can say it grows by a factor of 1.25, or I can think of it as a percentage. If I think of it as a percentage, you always have to be subtracting 1. So whenever, I'll just say percent means subtract 1. That's kind of like the big thing. So if I'm, oh, look, I'm talking about a percentage here. That means I'm taking the scale factor, which was 1.25, and I subtract 1. Well, that's 0.25, but that's as a decimal. And then to convert from a decimal to a percentage, you do, I guess there's 2 steps. You need to then multiply by 100. So I have 1.25. Here's my math off to the side. 1.25 minus 1 is 0.25. Okay. And then I multiply it by 100, which means I move the decimal place 1, 2 to the right, and my percent is 25. So the scale factor of 1.25 is synonymous. It means the same thing as 25% added to the total. They're the same way of saying the same thing. Okay. What about, so that was growth. What about decay? So instead of saying grows, I'm going to say shrinks, because it's decay now. Notice that it's decay because our scale factor is less than 1.89. I think everyone can nod their heads. Yep, that's less than 1, Mr. Sindel. Okay, so how can I say this? Can someone complete the sentence? It shrinks by a factor of what? Jade?
0.89.
It is 0.89 or 0.89. You don't have to have the 0, but definitely 0.89. Okay, and then this is the hard bit. What is the percentage that is being subtracted from the total? Wyatt?
Is that 11?
It is 11. How'd you get that?
Well, even though 0.89 is smaller than 1, we still need to subtract it by 1 because that's our rule. So if you subtract that, I thought of it as how do you get to 1, and that would be your leftover, and that's 0.11. So that's 11% is subtracted to the total.
Exactly. So it's when you subtract 1, you're left with negative 0.11, which means you're subtracting that 0.11 or subtracting that 11%. Exactly. Okay, so you guys know the ways to say things, and this might be confusing on the homework, but we'll see. So we have, what is it, two examples on the front, and then we have a time question on the back. Those can be tricky too. So here's your question. If the equation capital P of T is 1,348 times 5/6 to the power of T, if that represents the population of wolves every T months, then every month the wolf population, is it gonna either grow or shrink by a factor of blank? Well, first of all, we can answer the first part really easily. Is it gonna grow or is it gonna shrink? Is it gonna get bigger or is it gonna get smaller? One of these numbers is gonna be really important to us. Either that first one or the second one. Is this gonna grow or is it gonna shrink? Charles?
I think that is gonna shrink. I mean, no, it's gonna grow because 5 is greater than 1.
Because 5 is greater than 1. So I agree that 5 is greater than 1, but your scale factor is 5/6 is a fraction.
Oh, I thought the below one was time.
So it's only time when it's in the exponent. So it's kind of hard to see here, but this entire thing is the exponent.
Oh, okay, that makes sense now. Okay, so
So
then it
our
would
exponent over here
be,
is over 1.
it would still grow because 5/6 is, wait, no, it would shrink because 5/6 is less than 1.
There it is. All right. And everyone has that too, right? Shrinks 5/6 is less than 1. Nod head. You got it. We're good. All right. That was the easy part. The harder part is this, do I like what number goes here? Do I just put the scale factor? Do I write it as a percent? What am I doing? Any ideas? What?
I think you're gonna want to turn that 5/6 into like a decimal.
Okay. So that's 0.83 repeating.
Wouldn't it just be 5/6? Would that just be a factor of 5/6?
Yeah, exactly. All you have to do here is write 5/6 and you're done. Why? Because you see the word factor. Whenever you see the word factor, factor means write the scale factor. And you're done. This is the easier type of question. I'm going to give you the harder type of question in the second one, in example number 2. So far, so good. If you guys see the word factor, just rewrite the scale factor. You are done. All right. Example number 2. Okay, new situation. I have capital M of T is an equation that is that thing, and it represents the amount of money in the stock market every T years. Every year, some percent of the money is either added or subtracted to the total. And another way of saying that is every year the money either grows or shrinks by a factor of blank. So I'm quizzing you on both of them now. So let's do this first one. Well, this first one, I see the percent symbol, which means I have to convert this into a percent using these 2 steps. I see percent. So do those 2 steps. What is the percent? The same people over and over again. I can't call them Jade, Charles, or Wyatt. Andres, yeah.
20%.
It is indeed 20%. How'd you get that?
So 1.2, I subtracted 1, and then 0.2 times 100, which is the second step, and I got 20.
Exactly. Yep. Move the decimal place 2 to the right, you get 20%. And is that going to be 20% added or subtracted, Andres?
That's going to be added because it's bigger than 1 or greater than 1.
Exactly. Yeah. 1.2 is greater than 1. Perfect. Perfect. All right. So now we go to the second part, which is the easier one, guys. So I'm going to call on someone brand new. Can't be Jose, can't be Andres, can't be Jake, can't be Charles, can't be Wyatt. Someone like Jenny, Fernando, Sergio, or Jessica. Every year, the money, is it going to either grow or shrink? And then by what factor? All right, Jenny, cold call. Jenny, is this going to grow or shrink?
Wait, say that one more time.
Is the money going to grow or shrink? Your scale factor is 1.2. So is your money growing or shrinking?
Is it gonna grow?
It is going to grow. Why?
I low-key just guessed.
50-50 shot. You got it. Woohoo! Coin flip worked. It's because of this. It's going to grow because this value of B that you were looking at, 1.2, was greater than 1. So you can just, your answer would be 1.2, Mr. Sindel, is greater than 1. If it was less than 1, like 0.8, then it would have been a shrink. All right,
Mr.
thank you.
Snow,
And
I
then-
have to go now. I did the
Sounds good,
homework
thanks.
as well.
All right, nice. And then what is the number that goes right here between Sergio, Jenny, and Jessica? Or sorry, not Jenny, Fernando, and Jessica and Sergio. Those three. What number goes right here? What is the factor? A factor of?
You say 1.2.
1.2, exactly. It's nice and easy. Whenever you see the word factor, just rewrite that number. Thank you, Sergio. All right, let's move on to the back. Interpreting time. These can be difficult. So I have a new equation for you guys. 212 times blah, blah, blah. There it is. Ooh, there's a fraction in that exponent, as Charles was kind of pointing out before. That models the temperature of water cooling off every T minutes. Then the temperature difference is reduced by a factor of 3/4. It has that factor of 3/4, this factor that is right there of 3/4 every how many minutes? And the answer is whatever the denominator is right there, every 3.1 minutes. Done, the end. The answer here is 3.1. So if you're thinking, oh, well, that's just easy, you put whatever's in the denominator, you're going to get all the homework correct, and you're probably going to do all of the stuff correct on the quiz. But once you hit the homework for tomorrow, you might be confused because you really have to understand why. Why is that 3.1? It's because of this. If you plug in 3.1 in for your variable there, then that means that you're going to have 3.1 over 3.1, which is 1. And guess what? 3/4 to the power of 1 is 3/4. That's why it makes sense. So I don't know if I just confuse you even more, but if you have no idea what's going on, hey, just take whatever the denominator is for the exponent, you'll get the correct answer. Let's try a different one. Oh, I basically just explained this. I guess I should have read ahead. The question that you always want to ask yourselves is, what value should the value of t be, your variable, in order to have the desired scale factor? So, and then sometimes it's a little bit hard, right? So t over 3.1, what value should this be in order to have 3/4? How do I undo the exponent to make the exponent 1? And the answer here, as we just saw, was you need t to be equal to 3.1. The whole goal is, how do I make that exponent 1? That's the goal. So in this next example, t is going to be what? What?
6.9.
6.9. That's an easy one. This next one is harder though. How do I make this exponent 1? N is going to be what? Jade?
-3.2.
Good guess, but not quite, because if I do -3.2 times 3.2, I'll get like 10 point or -10 point something. But you're on the right track. How do you undo multiply by 3.2? Jose?
So do you divide this?
Yeah, so you'd have the n is equal to what then?
Would that be just 1? Or 0, I mean? I don't know, I'm confused.
If it was 0, then 0 times anything is 0, but you're on the right track. Yeah, Andreas?
Would it be 3.2?
So close, but not quite. You have to undo multiply by 3.2. How do you do that, Wyatt?
N would be equal to 1 over 3.2.
There it is, 1 over 3.2. If n is 1 over 3.2, 1 over 3.2 times 3.2, 3.2 is on the top and bottom, they cancel out, and you've just got 1. And very similarly, down here, What is t going to be to make this exponent 1? Andres?
1 over 1.5.
Beautiful. There it is, 1 over 1.5. So it's not as simple as just take whatever the denominator is, because there is no denominator for this one. 3.2 and the denominator is 1. Like, there isn't anything. So the question you really have to ask is, how do you get that exponent to 1? Or how do you get that exponent so that you get the correct scale factor? I'll put up here, get exponent to 1 for 99% of the cases. Get exponent to 1. Cool. Well, that's all I have for you guys today. There are the notes. I'll put a screenshot up there shortly. You guys have 10 minutes to do the homework. I think you have 2 or 3 homework assignments. I can't remember, but they're up on Khan Academy already. Can you guys give me a quick fist of 5 on our objective, which was to identify forms of exponential growth and decay and determine how time affects the scale factor? I'm getting 5. Ooh, chat popped up. Let me go look at that. A 4, a 5, a 3. Jessica, Sergio, Jenny, 3, 4, 3.89. All right, cool. Well, that's all I have for you guys.